Okay, so as I mentioned, if two vectors are parallel to each other, then one will be a multiple of the other, or they both be multiples of each other. So m, in this case, this shorter one is half of the larger one, so the half would be the multiple. Or we could say the larger one is twice the smaller one, so 2 would be the multiple. So when we're trying to show that OP is parallel to vector A plus B, then we're looking for this to be the case. The vector OP is equal to some constant multiplied by A plus B. Okay. Wait, I want yellow. So I coloured the yellow in as the constant. So that's what we're trying to show is true. So, for example, the constant could be 2, could be 1.5, could be lots of different things. And if we can show that OP is equal to some constant multiplied by A plus B, then it is we've shown that OP is parallel to A plus B. So let's see where we got to with this. If we want to go from O to P, well, we know that, let's get another colour. So we know that O to P is the same thing as O to A plus A to P. Now, O to A, we can clearly see is just 2A. And A to P, well, we don't know what A to P is yet, actually, but we do know that A to B is 3B plus 2A. So have we learned anything about what point P is? Okay, so it tells us that. Let's use some other colours. I'll change the colour of that. Let's find blue. So A to P is 2, and I'm going to choose green now. P to B is the three parts. So therefore, this part here, this A to B, can be separated into five parts, where the P to B represents 3 parts, and the A to P represents 2 parts. So that if A to B is 5 parts total, then A to P is going to be equal to so it's like this. Maybe I can do. I'm going to make a sort of diagram to show what I'm saying, just in case it's not clear. Okay, so this little shape up here is trying to represent what I'm saying here. It was 2 to 3. So out of the whole distance of A to B, we can see now that A to P is going to be 2/5 of A to B. And in the previous part, we worked out what A to B is. So therefore, A to P, so again, just to highlight here, the blue part is going to be 2/5 of 3B minus 2A. Okay, so now we can put this bit into here. Let's use yet another colour. I'll pick orange. So we're saying A to B, which is this one here, which we worked out to be this. So highlight that. No, sorry, I've highlighted. We want that to be in blue. A to P I've highlighted as blue, so it's this one here. So so we can say A to P is all of this. So 2/5 3B minus 2A. So I could highlight that bit orange, but it's probably more useful to highlight the whole thing blue. Okay. Yeah. Okay. So basically, just to recap then, O to P is the same thing as O to A plus O to P. I've worked out A to P as equal to all of this. And now we're just going to try to simplify this a little bit. So 2a plus, and we want 2/5 times 3b. So we just multiply the 2 by 3, so we get that's 6 over 5b minus 4 over 5a. Okay, that's what OP is, and this is the thing that we're trying to show is parallel to vector AB. So we're going to try to collect the terms together. So 2a minus 4/5 a. Well, to collect that, we need to turn 2 into a number of fifths. So 2 is the same as 10/5. So 10/5 a plus 6 over 5b minus 4 over 5a. Let me just check I'm doing this right. Yeah, that's good. Okay, so yeah, this looks good now. So because I'm going to collect this term here, the 10/5 a and the 4/5 a, and we end up with 6/5 a. Still got the 6/5 b. And now we can take a factor of 6/5 outside the bracket, and we have a plus b. And that's perfect because we can see that if OP is equal to 6/5 times a plus b, then it's a multiple of a plus b, and the multiple here being the 6/5. So going back to the colour I was using earlier on for the constant k, then that in this case is 6/5. So O to P is the same thing as 6/5 multiplied by A to B. Therefore, it is parallel.